of all, thanks for being here. In this video, I will explain LU decomposition method or triangularization method. So now we will go to the theory. LU decomposition method. What is the idea behind? What is the idea behind in the LU decomposition method? So in the LU decomposition method, we have taken an n by n matrix that can be written as product of lower triangular matrix and upper triangular matrix. A square matrix capital A can be a square matrix capital A can be a square matrix capital A can be decomposed into two square matrices L and U such that A equal to LU, where U is an upper triangular matrix, where U is an upper triangular matrix and L is a lower triangular matrix with diagonal elements being equal to 1. Actually, what is the lower triangular matrix? So the lower triangular matrix can be written here L11 0 0 L21 L22 0 L31 L32 L33. So the elements in the above the diagonal are 0. That is called lower triangular matrix. So what is the upper triangular matrix? So U11, U12, U13. The same way 0, U22, U23, 0, 0, U33. So this is called upper triangular matrix. So here this is the diagonal elements. In the diagonal matrix, the elements below the diagonal elements are equal to 0. Then that is called upper triangular matrix. So U11, U22, U33, that is the diagonal elements. So here we observe the below the diagonal element, below the diagonal elements, all are equal to 0. This is upper triangular matrix. So the matrix, the square matrix A is divided into, decomposed into product of upper triangular matrix and lower triangular matrix. In this lower triangular matrix, clearly situated that the diagonal elements being equal to 1. The diagonal elements being equal to 1. So we have taken the diagonal elements in place of L11 in this place. This is the diagonal element 1. This is the diagonal element 1. We have taken the diagonal elements 1. Okay. So next step. So here I am taking A is the 3 by 3 matrix. This is a 3 by 3 square matrix. So this matrix can be decomposed into the lower triangular matrix. This is the lower triangular matrix with the diagonal elements are being equal to 1, and this is the upper triangular matrix. So in the upper triangular matrix, the elements below the diagonal elements are equal to 0. In the lower triangular matrix, the elements above the diagonal elements are equal to 0. Okay, such that A equal to LU. So we write A equal to the given matrix A, the given matrix A, and this is A matrix. That matrix can be decomposed into the product of two square matrix L and U, decompose into two square matrices L and U. Okay, so now multiplying L and U and comparing on both sides, left hand side and right hand sides, we get the values of L21, L31, L32. At the same time, U11, U12, U13, U22, U23, U33 values. Multiplying on right hand side and comparing the elements to the left hand side and simplifying, we get the all elements in lower triangular matrix and upper triangular matrix. So that will be seen in the problem. So let's go to the problem first. This is the given problem. Solving the system of linear equations 2x plus y plus z equal to 5, 3x plus 5 plus 2z equal to 15, and x plus y plus 4z equal to 8. So in the method of value decomposition, so first of all we write the given system of linear equations. Now we express the system of linear equations in Ax equal to B form. Ax equal to B form. Ax equal to B form. So A is the coefficient matrix, X is the unknown column vector, and B is the constant matrix. So write A matrix. So 2, 1, 1, X coefficient 2, Y coefficient 1, Z coefficient 1. The same way in the second linear equation, X coefficient is 3, Y coefficient is 5, and Z coefficient is 2. In the third linear equation, X coefficient is 2, 1, 4. So sorry, here we have taking 2x. So sorry, 2x plus, this can be written as x plus 5 plus 4z equal to 8. Just we will see the next step that can be written, or so sorry. I'm typing here. This is actually that equation is 2x 2x plus y plus 4z, 2x plus y plus 4z equal to 8. So we express the given system in matrix form: 2 1 1 xyz, 2 1 1 3 5 2 2 1 4. That is the coefficient matrix. XYZ, this is the A matrix, this is X, this is equal to B constant matrix. So here A equal to, right, is the coefficient matrix, X equal to XYZ, and B equal to 5 15 18. Now as per the LU decomposition method, so what describes LU decomposition method? The coefficient matrix is decomposed into lower triangular matrix and upper triangular matrix. The lower triangular matrices having the entries in the diagonal elements are being equal to 1. So that can be written as, so let A equal to LU. That is equation 2. So this is A matrix. L. L is the lower triangular matrix whose diagonal elements are equal to 1. Whose the diagonal elements are equal to 1. And we have taken the upper triangular matrix. Now, on the left hand side, we multiplying 1 into U11 plus 0 into 0 plus 0 into 0. So, we multiplying the first row and first column. In the same way, first row and second column, and first row and third column. Similarly, second row and first column, second row and second column, second row and third column. In the same way, third row and first column, third row and second column, and third row and third column. The resultant matrix is displayed here. Now, comparing the elements on left and right hand side, comparing on both sides. So we get U11. U11 value is 2. Next, u12 u12 equal to 1. Next, u13 u13 equal to 1. So in the first row, u11 u12 u13 is obtained. In the second row, L22 U1. So what is the value? L21 U11 equal to, what is the value? This is 3. So that can be written as 3. But U11 value. But U11 value, what is U11 value? That is 2. So that implies L21 into 2 equal to 3. So L21 equal 3 by 2. So that's the same way L21 U12 plus U22 equal to 5. Okay. The same way L21 U13 plus U23 equal to 2. So comparing the corresponding elements on left hand side and right hand side. So we get the values in the next slide. So L21 U11 equal to 3. In the next slide, in the last slide, U11 equal to 3, U11 U11 equal to 2, U12 equal to 1, U13 equal to 1. So substituting in these values, we get L21 U1 equal to 3. But here U11 value is U11 value is 2. So that implies L11 equal L21 equal 3 by 2. Similarly, L21 U12 plus U22 equal to 5. 5. Here U L21 value is 3 by 2. Already in the previously we have to identify that L21 equal to 3 by 2 into U12. In the previous slide we have to calculate U12 value plus U22 equal to 5. So that implies U22 equal U22 equal to 5 minus 3 by 2. So 10 minus 3 by 2, that is 7 by 2. In the same way, we have to taking the L21 plus U13 plus U23 equal to 2. So L21 equal to 3 by 2 plus U13 equal to 1. That is calculated. This is L21 value. That is L21. Next U13 is 1. So U23 value is 2. So that implies U23 value. Okay. The same way, we calculated the remaining values also. We have to calculate the remaining values also. So all the values are displayed here. So in this step, I decomposed the given matrix A, the given matrix A into lower triangular matrix and upper triangular matrix. Okay. So the given matrix is decomposed into lower triangular matrix and upper triangular matrix. Now the procedure is, the given equations are expressed in the matrix form Ax equal to B. In the second step, we have taken A equal to Lu. So from observing that Ax equal to B and A equal to Lu, so now substituting A value Lu here, so we get Lux equal to B. Here A equal to Lu, so A equal to Lu, X equal to B. Now I am taking Ux equal to Y, Ux equal to Y. So Ux equal to Y, in the equation 3 we have taken ux equal to y, then equation 3 can be written as ly equal to b. We know that already x equal to xyz. In the first slide we have taken x equal to x y z. Here we have taken ux equal to y, where y equal to y1 y2 y3. So Ly equal to B. So L is a lower triangular matrix having the elements 1 0 0, 3 by 2, 1 0, 1 0 1. That is displayed in the above top of the screen. So now we have taken L value, lower triangular matrix. So this is the L matrix. Next Y. Y means we have taken Y1, Y2, Y3. Next, equal to B matrix. B is constant matrix that is already written in the first slide. So that value is 5, 15, 8. Now we observe that, so we multiplying two matrices in left hand side. So 1 into y1 plus 0 into y2 plus 0 into y3 equal to 5. So y1 equal to 5. In the second row, so 3 by 2 into y1 plus 1 into y2 plus 0 into y3 equal to 15. So in the same way, 1 into y1 plus 0 into y2 plus 1 into y3 equal to 8. So now we have to solving y1 equal to 5. So that y1 value is substituted here. That value is substituted here. So 3 5 is 15, 15 by 2. So that move to right hand side. Y2 equal to 15 minus 15 by 2. That is also same 15 by 2. So y2, y1 plus y3. y1 is already 5. So y3 equal to 8. So now using forward substitution, we get y1 equal to 5, y2 equal to 15 by 2, y3 equal to 3. Once we get the values of y, okay, so here we get y, y1 equal to 5, so that is 15 by 2, and the next that is 3, 5, 15 by 2, and 3. So this y value we are taking here in equation 4. From equation 4, ux equal to y. So u is upper triangular matrix. 2 1 1 0 7 by 2 1 by 2. Observe that this is u. So substituted in equation 4, ux equal to y. U is 2 1 1 0 7 by 2 1 by 2 0 0 3. X equal to x y z y. What is the y value? 5 15 by 2 3. That value is so this is u value, this is x value, this is y value. Now we have to multiply the matches on left hand side. So here we get 2x plus y plus z equal to. So we have taking the first row and along with column. So we get to 2x plus 1y plus 1z equal to 5. That is the first equation. From the above we have to write. The next second equation has 0 into x plus 7 by 2 into y plus 1 by 2 z equal to 15 by 2, 15 by 2. Next 0 into third row and first column. 0 into x plus 0 into y plus 3z equal to 3. That is the second row. So from here solving the backward substitution here, z equal to 1. So now substituting z equal to 1 here, we get 1 by 2. 15 by 2 minus 1 by 2, that is 14 by 2. So that is 14 by 2. So 2 2 cancel. So 7 1 ja, 7 2 ja. So y equal to 2. So now we have to substituting here y equal to 2, z equal to 1. So 2 1 3. So 5 minus 3, that is 2. So 2 2 cancel, x equal to 1. So on solving we get x equal to 1, y equal to 2, z equal to 1. So this is the solution. This solution is satisfied by the given system of linear equations. This is the required solution which satisfies the given system of linear equations. This is the LU decomposition method. By using LU decomposition method to solve the system of linear equations. Next we will see the another example. Solve the equations by using LU decomposition method. So as usual, we express the given equations in matrix form Ax equal to B. Express the given equations into matrix from Ax equal to B. So A is the coefficient matrix 2 minus 1 3 minus 3 4 minus 5 1 3 minus 6. And the coefficient constant unknown column matrix is xyz, and constant matrix equal to 1 0 0. So the given equations in expressed in Ax equal to B. Here A is the coefficient matrix, X is the constant matrix, and B is unknown matrix. Now we have to taking B is the constant matrix. Now we have taking A. A equal to the matrix A is decomposed into lower triangular matrix and upper triangular matrix that is specified in equation 2. So in the lower triangular matrix, we have taken the diagonal elements as 1. In the upper triangular matrix, as usual, we write. Now we multiply the elements in the right hand side and comparing to the both the left and right hand side. So we get u11 equal to, comparing on both sides, we get here u11 equal to 2. Next u12 equal to minus 1. Next u13 equal to 3. So u11 equal to 2, u12 equal to minus 1, u13 equal to 3. Next entity, what is next? L21 u11 equal to minus 3. So already here u11 value is already calculated a few seconds back, that is 2. So here L21 into 2 equal to minus 3. So that implies L21 equal to minus 3 by 2. So now L21 value calculated here. In the next we have comparing the second row, second column to the left hand side. So L21 U12 plus U22 equal to 4. So here L21 is already know minus 3 by 2 and U12 is calculated as minus 1. So that two values are substituted here, minus 2 by 2 into minus 1 plus U22 U22 equal to 4. So from here U22 equal to 5 by 2. So L22 equal to 4 minus 3 by 2. So 8 minus 3 by 2, for that is 5 by 2. Next we have to comparing the second row and third column element. Second row and third column. L21 U13 plus U23 equal to minus 5. So we have taken, already we know that L21 value. So L21 value is minus 3 by 2. So L21 value is minus 3 by 2, U13 equal to 3 plus U23, that is the unknown element. So minus 3 by 2 into 3 plus U23 equal to minus 5. So that value is minus 9 by 2, minus 5 plus 9 by 2. So that can be written as minus 1 by 2. Similarly, the remaining elements also calculated. So we have taken the first element, we have taken, so this is the first element, this is the first element, L31 U11 equal to 1. So but U11 equal to 2, so L31 equal to 1 by 2, that can be seen in the L31 value. In the same way, in the same way L31 U12 plus L32 U22 equal to 3. So here, from here we have to calculate L32 value, because U22 is calculated previously, U12 is calculated previously, and L31 is calculated previously. These values are substituted in this equation. So we get L32 value. L32 value is 7 by 5. Similarly, we have to calculate U33. So L31, U13, L32, U23 values are calculated from here. So from that we have to calculate U33 equal to minus 6. Now we have to substitute all the values in lower triangular matrix and upper triangular matrix. So the matrix A is decomposed into the product of lower triangular matrix and upper triangular matrix. So once this step is completed, now we have taken the equation 1. Now we have taken the equation 1 from Ax equal to B and taking A equal to Lu. So we have taken that. So Ax equal to B and A equal to Lu. Now substituting A value, A equal to Lu here. So we get so from here we have to take in. So A equal to LU, A equal to LU. So LU equal to B. So from UX equal to Y, we have taken EX equal to Y. UX equal to Y in equation 3, that is denoted as equation 4. That is denoted as equation 4. So the equation 3 becomes Ly equal to B. Ex equal to Y, we have taken Ly equal to B. Here L is a lower triangular matrix and Y is, we have taken Y equal to Y1, Y2, Y3. That is the column matrix Ly that equal to B. B is also 1, 0, 0. Now we have to compare on both sides. Now multiplying the two matrices on left hand side 1 into y1. So first row and first column 1 into y1 plus 0 into y2 plus 0 into y3 equal to y1 equal to 1. In the second step we have the second row and first column. So minus 3 by 2 y1 plus 1 into y2 that equal to 0, that is 0. Next 1 by 2 into y1 plus 7 by 5 into y2 plus y3 equal to 0. Now we have to calculate it. Y1 value is already 1. Y1 value is substituted here. Minus 3 by 2 plus y2 equal to 0. So y2 equal to 3 by 2. From the first equation and the second equation, y1, y2 values are substituted in the third equation. Here y1 value is 1 and y2 value is 3 by 2. So we get y3 value, that is minus 13 by 5. Once we get the value of y, so that value is substituted here from here, equation 4. In the equation 4, U is the upper triangular matrix, X is the unknown column vector XYZ, and Y equal to already here calculated 1, 3 by 2, and minus 13 by 5. So now multiplying left hand side, minus 2 minus 1, 3, first row and first column, and equating to the first element in the right hand side. So we get the equation 2x minus y plus 3z equal to 1. Next, similarly, we have to calculate the second row and first column and equating to the second element in the right hand side. So 0 into x plus 5 by 2y minus 1 by 2z equal to 3 by 2. The same way, third row and first column. So 0 into x plus 0 into y minus 34 by y by z equal to minus 13 by 5. So simplifying that from the third, from this step, we have to calculated z value and substituted z value from here. We have to calculated y value and yz values are calculated from here. We have to calculated. We have to find out the x value. So on solving, we got x equal to 9 by 34 and y value is 23 by 34 and z value is 13 by 34. So these are the solutions. So this is the method of LU decomposition method. This is the method of LU decomposition. So in this method, the coefficient matrix is decomposed into lower triangular matrix and upper triangular matrix. With the help of lower triangular matrix and upper triangular matrices, we have to identify the solution of the given system of linear equations. Okay, we have to any doubt, so please comment so that I will solve your doubts. So thank you for watching the video. So if you like the video, like, share and subscribe. Thanks for engineers.